Hello, everyone. Welcome to Serverless webinar series. My name is Anshu Agarwal, and I am co-founder and CEO of Nimbella, a serverless platform provider. Today, my guest is Girish Vengassery, an engineering leader at Here Technologies. Welcome, Girish.
Hey, thank you, Anshu. Glad
Hi.
to be part of it.
It's great to have you here, Girish. Before I ask you the serverless and cloud computing questions. Tell me about yourself and what you do at Here
Okay.
Technologies, and a little bit about Here Technologies.
Okay. Yeah, sure. Glad to share more on that. So my name is Girish. I come from Kerala in India, and I'm currently working in Mumbai. I'm settled in Mumbai. I'm a senior engineering manager at Here Technologies. Been with Here Technologies around 12 years or so. Starting to work on some of the initial location-based tools, primarily building maps. That's what we primarily work on. So I was part of that, and then took a journey of like moving things into cloud. During past 10 years, various aspects of cloud computing as well as location technology in general. For example, like moving from a desktop platform to more a web-based and cloud-based tools and server-side components stack, automation of some of the mapping itself, right? How do you update maps when things change in real world, and how fast you can do. There were a lot of manual editing that used to happen in map. A lot of those things were automated. It was really fun, to think about how do you update certain things when real world changes. How do your digital representation of that changes? Those really enjoyed. I worked as an architect in many of those projects. Um, Post that, I moved into highly automated driving related services and tools that was primarily meant for creating high definition maps. So the normal maps is used by humans. So if somebody, I mean, if the map is not accurate when you drive and you get a direction, you might look at the road and you won't probably see a turn that the map is talking about, and you may not take that turn, right? You might take the next turn. So you have a backup, like you as a human, you know what you're doing. So you don't probably make that mistake of what map says incorrectly. But if you think about autonomous cars driving based on these instructions from the map, not only instructions from the map, but also from the sensors that maps, I mean, the cars have. But even then, if you're on top of a bridge and it takes, it tells you to take a turn because the map was incorrect, it's probably going
Yeah,
to
it would be
be
devastating.
catastrophic. Yeah. Yeah. So
Yeah.
you don't want to do that. So these maps are very highly precise, I mean, centimeter precise representation of the real world. So it's
Okay.
kind of making the 3D worlds in that. So we worked on some of the tools and the backend processing aspects of these kind of making those kind of maps. Now we are moving to automating those building of those maps. So working on some of those projects. So these are some of the things that I was working personally at Here.
Very exciting. Latest technology, exciting. So,
Yeah.
tell me, what has been the cloud computing journey at Here? How you have evolved over time? Just give us a snapshot of, walk us through that.
Yeah, so to give you so I briefly talked about some of the here products. Like I talked about Map.
Hmm.
Map as a product. So we provide map data for other companies, like especially OEMs, the car companies who have inbuilt navigation systems in the cars. The Here also provides map data for a lot of enterprise customers, like
Okay.
the ones who wants to manage their logistics, and how do you know where are your materials, and supply chain aspects, everything, the logistics part of it. So there are enterprise customers as well who use these mapping solutions on
Okay.
on their cloud platforms and server side aspects. And then you have, so now these are more content products. Like, what we are selling is not really software, but really data that is
Yeah, data.
produced by us, right?
Hmm. Yeah.
But then as here moved into more of a service and platform company, because selling the data is one part, and that's highly, that's where we produce most of the revenue still. But as a company, we wanted to move into more of services on top of the data. So we introduced location services. So
Okay.
you can not only buy the data, but you can also have APIs where you don't have to really buy the data. But if you're building
Mm-hmm.
your own navigation applications, you can basically use the APIs where you can provide an input like point A to point B. How do you go? And it will provide you routing options that you can you can use in order to build navigation, right? Turn by turn navigation
Mm-hmm.
instructions
Mm-hmm.
for users. So these are
Yeah.
some of the PND devices or mobile phones. I mean, many of us use those things, in today's world, either in a car or in a phone, in some way. So these APIs are provided. These are more of developer-facing, APIs, so developers can develop their own applications, web applications, mobile applications, all those.
Yeah.
The third part of that is, the next is the platform. So it's not only developers building applications for client, the client applications. It's also you have a lot of scope in terms of using this location data, bring your own location data like private maps, which you may not want to share with somebody else. You may have your own locations which are private or
Uh-huh.
temporary.
Uh-huh.
Bring those kind of information into the maps, and then you can actually build routing around that private data, which is on
Mm-hmm.
top of the base map data.
All right. Girish, thank you for that introduction. I wanted to ask you, what has been the cloud computing journey using your technologies?
Okay, so like I mentioned, we initially started, being mostly, in-house and desktop-based, the map editing tools and all that we worked on. But as things moved into web, a lot of editing capabilities and building maps moved into web. There are a lot of server-side components introduced to process data. So all these were, initially in-house. And then we slowly started moving into this. This was around 2010, 12 time frame. We started moving this into cloud. So that was the first experience of moving into cloud, learning the cloud technology stacks, building building the teams to have those knowledge bases. So that's how we moved into first into cloud. Slowly, a lot of these services moved into cloud. Now I talked about like initially at that point it was more of data that we were dealing with. Like our
Mm-hmm.
products was data products, and then most of the content was map content is what we sell. But slowly we also started building, the services around it, the location services to, for somebody building an application, client application who wants to use, a map component or a routing component in it, where they want to provide, navigation,
Mm-hmm.
turn by turn navigation into that. Then they don't have to build all the map, map the routing algorithms and everything their own, but rather they could use the APIs, the location services that we provide. You provide the start and end locations, and it will provide you a turn by turn set of instructions that you can either play as an audio, or you can provide it as text. So that's
Mm-hmm.
that's how those kind of services came into picture. So these services were again all deployed in cloud. Initially, it was all deployed in primarily we were using AWS at that point as a cloud vendor, and then we started using the EC2 instances, the traditional way of building
Okay.
building the
Building
and
the apps.
deploying
Mm-hmm.
things, right,
Mm-hmm.
the apps. So mostly you basically moved your infrastructure into the cloud, but you're still running everything on a machine, installing everything. So that's how the initial journey started. Slowly it
Okay.
started moving into more containers, like Docker was introduced, and things were more containerized, so you could basically deploy it in anywhere. Then the container orchestration methods came into picture. Like we initially used Mesos Marathon Mesos as a container orchestration. Later, different teams start exploring. I mean, the cloud providers came up with more options. Like for some time, we were using the AWS ECS Elastic Container services for deploying things. So that's where it all started. I mean, it all started and moved into. Now we mostly use Kubernetes-based, the clusters. Here itself now, on top of these location services and data, now we provide a platform where you can actually deploy things into our platform. For example, bringing your own data, private data sets, bringing your own services, so that services need to be deployed. But you don't really deploy those services by building your components and building your own Kubernetes,
Yeah,
Docker instances and
that would be very
everything. So
painful for developers.
yeah, right. Yeah. So
Yeah.
it's more like we provide a platform where we internally have Kubernetes-based deployment platform, what we call as deployment platform. That's kind of a taking into the next level of cloud native and serverless, because we don't want our customers to really, if a customer has a preference to have one or the other, or they want to have multiple for whatever availability reasons, so they will want to do that. So the deployment platform is something that's an abstraction on top of Kubernetes that here builds, and then our platform, the actual platform where things runs, data processing, whether it's a batch processing, whether it's a stream processing, those aspects are you just need to write the code and deploy or upload the code, and rest of the scaling aspects and everything behind the scenes taken care by. Right? So that's where we are now. So
Okay. So,
naturally where we
is this a hybrid cloud environment, or you're all in public cloud? Do you have
it
any
is
private
hybrid.
infrastructure? Okay.
So we had private infrastructure. We are almost getting rid of all of that and
All of it. Okay.
completely public. So initially, when we deployed the Marathon Mesos, it was actually in-house cloud. So it wasn't really in AWS, and then we moved that into an AWS cluster. AWS cluster moved all those there, but we still had certain old old systems that still ran in our private cloud, or even some of the data centers, but that's all going to go away in a few months.
Yeah, and but private cloud has a different definition also. So if you have a virtual private cloud in AWS or Google or Azure, it's still a private cloud, but it's running
Oh
in
yeah,
public infrastructure. So I'm assuming you have a
we
virtual
have
private cloud.
many of them, because if you
Okay.
see the company size, it's around 9,000 employees, and probably around around 30 to 40% of that is probably engineering. So we have a lot of teams which works on various aspects of these data part, location services platform. So almost all of these these internal data related services that we run is almost always in VPCs, within private clouds, which is not exposed to outside. But the goal for us is to actually also bring those into our platform, so that so that others can build their own maps using the same tools and technology stack that we use.
Okay. And do you care about multi-cloud?
Oh, we very, very much, right? Because there are a lot of customers who use these services, and there are a lot of customers who who produce these these location data now. So unlike 10 years back, 15 years back, you basically, we used to drive our own cars. We still do, but now drive our own cars and collect the street imageries and LiDAR and all for this high precision maps. But that's changing rapidly, because we cannot drive our own cars, which is very expensive cars with expensive cars. We can only drive it in every few months or so in a street, that to major streets, streets or highways. So that's kind of going off, because now you have a lot of devices on the road, right? The cars itself is a digital. I mean, it's as good as getting a phone now. It's completely online connected. You have many other IoT devices and various aspects which provides location information and various metadata around that. So we're starting to to get into a situation where your map is fundamentally one part of the location data. But then you have a lot of dynamic and more, static dynamic, like weather conditions, with traffic conditions, more dynamic data like that on top of the map. Then you also have all this information, like cars report accidents. When a car can
Mm-hmm.
detect when there is an accident on the road, so it detect
Mm-hmm.
those incidents. It
Mm-hmm.
can detect road closures or lane closures and report back, so that the other cars can change the lanes way ahead of before it reaches there. So more convenient driving. So all those data flows in. So now what happens is these data is not collected by not by here, but these are actually shared by our vendors, who are the car companies and many others, right? So
Yeah.
whoever wants these to bring these data, they may have specific requirements on which cloud they want to choose, or if they
Yes.
want to keep things in different clouds, or
Yeah.
data
Yeah.
privacy, all those aspects around that, right? So when we provide services of this sort, we definitely would want to respect what the customers want and
Mm-hmm.
provide those options. So that's where the multi-cloud is. So that's where we are already going. The Kubernetes cluster and the deployment platform we develop is meant for multi-cloud. So you don't have only one vendor or the other.
Yes. Yeah. Kubernetes is a great normalizer across clouds. So
Exactly. Yeah.
that is wonderful thing about it.
Yeah.
Um, when you started your cloud native journey, did your developers feel overwhelmed by the number of services they had to deal with and understand? How did you overcome that? How did your team overcome that hurdle?
Um, I think it's in both ways. In some way, when you use a cloud native, when you're directly using cloud native, cloud native and a serverless service, or when you deploy that, that's much easier, because you don't really have to worry about all the deployment, DevOps aspects,
Sure.
everything. So
Hmm.
that makes life easier for them. But if you're trying to build something as a cloud native service, which is what we were also doing in many of these cases, there you definitely have to provide, abstract a lot of things, which developers don't have to worry. So that part is really where the when people start working on those things, you had to basically understand the whole Kubernetes fundamentals,
Yeah, absolutely.
which is
Hmm.
an extensively
Oh, yeah, yeah.
broad area,
I know.
right? It's
Yeah.
so that was one part. Then how do you deal with logging? How do you deal with alerting and all the other things around it?
Yeah, yeah. Mm.
Like
So there
Splunk or
probably
Terraform and all
there
that.
is a lot of
There is,
training
yeah.
and
There's a
understanding.
training,
Okay.
yeah. So yeah,
Hmm.
that's how it goes. Yeah.
Okay. Um, how is serverless fitting into your future at here? You mentioned serverless, you mentioned Kubernetes,
Yeah.
and so that's container workloads, but serverless is more function workloads type stuff. How does it fit? Could you talk about a use case that you're using just serverless for, or a combination thereof?
Yeah. So uh, hopefully you're hearing me properly, right?
Yeah,
Just
yeah.
confirm. Yeah.
Hmm.
Okay. Okay. So yes, I mean, I talked about the here platform. So let me take use cases from that, because that's where
Okay.
we are going for, moving ahead with. There are there are customers we are onboarding into that. Um, so think about so one of the here, I mean, the major here, our vision is primarily to to make the world more autonomous. That's our vision as a company.
Okay.
So when you talk about autonomy, it can be many things, like driverless cars. How do you travel from one place to another easily with with, so for example, like take an example of you traveling, you're flying from one country to the other today. It's not really a seamless experience. You basically have a flight schedule where you cannot really just start from your home with one application to guide you throughout, right? You need to switch between applications, and a lot of those uh, complexities, or it's not very seamless. So that's one way of you talking about seamlessly moving from one place to the other by
Mm-hmm.
connecting between many different modes of transportation, right? That's kind of helps people to move much easier, smooth. Autonomous cars I talked about, you don't drive anymore, or you only drive when there are situations where car is extremely fussy about driving itself. So
Yeah.
those are the aspects that we are moving towards. So the autonomous world now. Um, another specific use case I can talk about is smart cities, and how do you deal with
Mm-hmm.
accidents or hazards. Say, for example, you have connected devices. That's another part of technology, expansion that's happening to 5G and connected devices. So all that, and then machine learning, of course. So when all
Yeah.
those comes together, you have this what do you call it? This use case I wanted to talk about this. So you have a fire alarm in each of the buildings, or smoke detectors in the houses. So those are primarily hardware devices which detects, senses something. So you have sensors everywhere. So think about a company which produces these sensors, and they are connected now. Basically, you can report the location of that device. You can report the status of
Mm-hmm.
that device.
Mm-hmm.
And then how so one of the use cases that if that company wants to build their own infrastructure for mapping all these devices they're selling and tracking where the fire accidents happens, here offers the platform or a set of layers where they can stream their data from these devices directly, right? And then that kind of use case where the data can be made available in here platform, that kind of avoids them to build their own infrastructure for that. Secondly, if you build your own infrastructure, you're only going to have that particular data set. But what here offers is you may have other companies other companies or providers providing their own data layers. For example, fire engines. A
Mm-hmm.
government authority may be providing fire engine locations live and their status, those aspects. So you have another layer of data over there. Now think about traffic lights. All traffic lights connected, the locations known, their current
Yeah. Yeah.
status known, and you can
Mm-hmm.
actually control those traffic lights. Now, if a fire happens in one of these buildings, you immediately can listen to that. So as a developer, I can basically write code, which again, that's where the serverless part is beautiful, because I can write some code which can directly be deployed to listen to certain events in the fire
Yeah.
alarm
It's
based layer,
event driven. Yes. Uh-huh.
right? And then event driven, and then I can access okay, there's a fire in a particular location, and then you get all the fire engines near that location within certain kilometer distance. So you got those hold of those fire engines. You can
Uh-huh.
route the fire engines with the considering the traffic situations, everything, the fastest route, or whatever that is. And then once that fire engine starts moving to the location where you have fire, think about the traffic lights layer that you can access and control the traffic lights in a way that in that route, it is optimizing the traffic in a way that the fire engine can smoothly go through, which means when the fire engine is a particular location, you may get like the next few traffic signals already green, so that the traffic is moving,
Mm-hmm.
but you don't really block the entire route, with a everybody blocked.
Wow.
So
Mm-hmm.
that's kind of an automation, right? So in between all this happens, you didn't see any human being except probably at this point a driver driving the truck. I mean the fire engine. Maybe that might get automated as well at some point, but that's kind of a use case. So if you see a developer perspective of this solution, they would want to simply write some code to orchestrate between these events and directing
Yeah.
the
Yeah.
vehicle to the
Yeah.
location, right? So that's kind of a use case
That
that's
is a
primarily a smart city use case. There could be many. As more and more devices gets connected to internet, it's becoming more and more smart, and you can only imagine how we go another 10 years.
that is a very very that's a perfect use case for serverless actually, because you're firing functions based on the event. So it's something is happening that
Exactly.
fires a function, then something happens, it fires, and it's just chain of
Yeah.
events that takes care of. Okay, wonderful,
Yeah.
wonderful. So now coming to your developers, okay.
Mhm.
Have you seen feature velocity after adoption of serverless? Like
We,
you've been
yeah, I mean,
internal, yeah,
definitely
yeah.
internal. Even for external, like we started with certain customers. We added more and more features, into this platform. So there is a lot of adoption of that location platform. We get new customers who bring their, the data. So it's much faster for them to bring their data now into the platform. Say, for
Because of the
example,
adoption, because of the
because of the
adoption of a
adoption,
platform.
right?
Okay. So
Right.
of the
So
serverless platform within your development environment. Okay.
that's right.
And
Yeah. Even
and
as
do
a product for external customers.
and could you characterize in terms of developer productivity? Have you seen 50% developer productivity, more than that? I mean, do you measure developer productivity in a way that you can characterize it?
Um, I'm not really sure about that because it's more of like, more of our customers who are right now, getting the benefit of this. Internally, we actually deploy a lot of things into the same platform. I mean, same platform, and and make use of that. Definitely, there is there is a lot more that we can do today compared to if you deploy all these things independently
Okay.
into different servers, right? So I wouldn't really probably be able to tell a specific number, but I, it's definitely
Okay.
much more easier.
Yeah, yeah. I mean, one of the benefits of serverless technologies is that it improves developer productivity significantly because you're not managing infrastructure, you're just coding logic. Or
Yeah,
so it takes away that burden.
yeah.
And
It also, I mean, some of the things we also notice is that it also brings certain other challenges, like debugging, and also your serverless platform should be providing those capabilities, right? Whether
yeah.
that's monitoring, debugging. Then logs, making those available easily.
Hmm.
All those things are, it depends on all those capabilities available also in this serverless platforms.
Absolutely. Yeah.
Testing, for example, another one. Yeah.
Yeah, I know you, it brings, it was my next question. What do you think is missing or lacking? So I guess there are challenges that you found with monitoring, debugging, and logging, etc. Where you probably have to bring other additional tools.
Yeah, right.
Okay.
That's right. Yeah.
Um,
So it is if yeah.
so this is really my last question, but it's for the benefit of other companies who may be thinking of going to a serverless journey. What kind of skills or competencies do you think are needed for an organization or an individual to adopt serverless solutions, or something that makes their development kind of cloud native or born in cloud right away? So, what would be your advice in terms of skills and competency?
Yeah, I mean, so few things on, there are serverless within the, within each cloud vendor, right? So you can stick to, certain serverless technologies that they provide. For example, we used to have AWS, Lambdas used, in many projects. But then one of the things that's when you get locked into that particular vendor, even though it's serverless and but that's natively provided by the vendor. But then you would want to, if you really want to move between clouds, then definitely you would want to do some, some of these serverless technologies that is built on top of this and abstracts those, those
That's correct.
underlying,
Yeah.
um, right, the underlying cloud platform
So,
itself.
underlying
It's
specific cloud providers. Yes. Yeah.
yeah,
Yeah.
specific
Yeah.
cloud providers. Yeah, it's like how we used to do this. We used to write C++ code, compiles into Windows and Linux and all separately, and then you run it, and then these Java kind of platforms came in, and it kind of took it out independently again. So same way, right?
Yeah.
Your Kubernetes kind of allows you to run this into multiple platforms. So that's one thing. So you would definitely want to have certain expertise on primarily Docker, which is maybe that's the core of all these things, where things starts to move
Okay.
into a more flexible deployment pattern. So Docker is definitely one thing that the developers should know about. Docker can, the Docker, what do you call, farms like Kubernetes or any of those, those, but Kubernetes
Okay.
is probably the one which allows all of these cloud native aspect more than any other, other cloud platforms. So those are primarily where those skills that would need that would be required, and other things could be like a lot of these cloud native platforms allows to write the code as code snippet or methods or functions. Right, so your way of writing code is probably no more the same way as before. Like, you don't write like an entire application, a
Mm-hmm.
structured, complete full application code that runs in a server. No, now you're starting to think more of smaller chunks of code. So you may need to have certain, certain different way of thinking how you write it, what languages you write it. You get a lot of flexibility to write certain, many of these platforms allows you to write it in maybe like 5 different languages. So there's a lot of flexibility on that aspect. So you may want to learn those, those, and many times I think most of these languages are coming into I mean, if you learn one of them or two of them, then you probably could code in another, 4 or 5 of them. So learning those and knowing those kind of languages, which is more, more used in this, would be another aspect. Debugging and debugging and testing in those kind of environments would be also a skill that you would know, you should learn or you should know. So those are some of the things I can think of.
Okay.
Maybe
And
other more.
what are there any language preferences these days, or it's changing all the time? And are there particular
I mean,
languages that mhm, are suited?
there are, I believe, the languages which is JVM based, or the languages which is more of like the JavaScript, TypeScript kind of languages, or
Okay.
Java, Scala, Kotlin,
Okay.
those kind of languages. I believe those are pretty popular in these these platforms.
Yeah.
Yeah, and Python for sure. Given the
And Go,
popularity of that
I
in
guess.
all the machine learning and even more. Yeah, Go,
Yeah.
right, Go. Yeah,
Mhm.
those. Yeah.
Okay. All right. Okay, great. Well, thank you so much, Girish. It was very insightful. Really appreciate, and the work that here is doing is very exciting. I drive a self-driving car, so I benefit from all the innovation that has gone in
Yeah.
this area. So, well, thank you. Appreciate your time, and hope to have you again sometime.
Sure. Yeah. Thank you so much for for inviting and giving me this opportunity.